Okay, time to start. So, if you're just joining, my name's Julian. I'm the machine learning guy, and I'm going to give you a headache this afternoon. So this session focuses on Sagemaker. So it's going to take you through the different features in Sagemaker. If you've never heard about it, no worries. I'm going to show you how to use it. We're going to run some notebooks, and I'm going to cram all those new reInvent features that I mentioned this morning into this talk as well. So it's going to be quite dense. So let's get started. So as explained this morning, our mission is to let all of you do machine learning. It doesn't matter if you're just starting with it or if you're an expert. We try to bring you the APIs, the building blocks that you can use to either start experimenting or keep scaling, keep building bigger things. And again, as explained this morning, this is the stack. And in this talk, we're really talking about that middle layer where we need to have full control over the machine learning process. We want to use our own data sets. We want to use potentially our own algos or use existing algos. But anyhow, we want to control exactly what's going on, but we don't want to spend a minute managing infrastructure, okay? We don't want to deal with servers. We don't want to deal with clusters. We don't want to deal with SSH keys and all those good things. Except here, we want to do machine learning, and that's what we want to focus on 100%. So I'm going to show you how to do this. But before we actually get started, so who's already doing machine learning today? Even small scale, that's okay. All right. So let's take a few minutes to go through the typical machine learning process, okay? Just to set the stage and see what the pain points are and how Sagemaker helps. So it starts with a business problem, okay? So let me repeat that. It starts with a business problem. Let me repeat that. If you don't have a business problem, stop right now, okay? I'm still meeting people who want to go into machine learning because, it's like that Dilbert comic, right? It's the boss shows up to your desk. We need a machine learning strategy, right? Okay, those of you who are old enough to remember big data 10 years ago, how did that work out? Yeah, you're laughing, so I'm guessing it turned out just the way it turned out for me, which was pretty bad. Okay, we need a big data strategy. Because probably they played golf with a friend on the weekend and he had a big data strategy. And well, you need to have one for the next game, right? Next Sunday. Okay, so I'm just kidding, but it is seriously a major problem. So some things need to be defined before you actually go into the whole thing, into the whole machine learning process. Okay, what's the business question you're trying to answer? Okay. So you need to have a list, and probably, I'm guessing there are plenty of problems in your companies and organizations, stuff that you've been trying to solve for years and haven't solved. Okay, so let's shine a machine learning light on those and see if that works. Okay, so this is called framing, trying to come up with a high-level approach based on data that could actually help answering the question. Okay, and sometimes you will stop right there too, because not all problems in the world could be solved with machine learning, unfortunately, right? Which means France will keep rioting for a few more years, I suppose. Not everything can be solved with machine learning. Maybe we need AI government. Maybe that would stop us from rioting. Who knows? But some problems simply cannot be solved with data. Think about, regulatory problems, compliance problems, competition problems. Not everything can be solved with data. So assuming it is possible to solve it with data, then you need to start collecting data, integrating data into a central repository. And please don't get me started on data lakes. I don't want to get there, but this is probably what you need to look at. And you need to clean the data and transform it and make it nice, right? Because your real life data is usually terrible. So those of you who do machine learning today, how much of your time do you spend cleaning data? Yeah, over 50%? 80%? Okay, 80% is the number I was looking for. Thank you, because I think that's the real life metric. So in a week's work, you're going to be cleaning, accessing, cleaning, gardening, weeding out bad data, and then maybe if you're lucky, you get 1 day of actual work. Yeah, does that look like your life? Yeah, sorry about that. But it's true. It's true. So hopefully, Sagemaker, Ground Truth, and so on, they can help you a little bit with that. At some point, you have data that you kind of like. You want to start visualizing it. You want to start building features. So features are high-level variables built from the raw data, and those high-level variables will help you build a model. Okay, the example I take all the time, if you've never heard about feature engineering before, imagine you have a customer data set where one column is the street number, one column is the street name, and one column is the zip code. Okay, so street number all by itself it doesn't mean anything, right? Street name by itself doesn't mean anything. Okay, I guess there's a Waterloo Road everywhere, right? So that doesn't tell you a lot. Zip code, okay, that's interesting, but it's probably too general. So if you need precise location data in your model, if that matters, then maybe you need to engineer a new feature by concatenating those three things, like street name, street number, and address. That gives you a precise location. Maybe an even better feature would be to compute latitude and longitude for that address. Okay, and then you can do geolocation predictions, etc., etc. Okay, so very basic, very silly example, but that's what feature engineering is. Starting from raw data and building, higher level features that probably a human would look at to decide what to do. And then once you have that, you train and you train and you train and you train, and you try to figure out what the right parameters are, and you do this hundreds of times, and now you start. After cleaning stuff for 80% of your time, now you start doing DevOps for 80% of your time, building clusters, fixing clusters, scaling clusters. Yeah, life is not good. It's even worse if your model doesn't work, because you have to do it all over again. But okay, at some point you get lucky and you have a model that you like and you need to deploy it in production. And now you're into real trouble, because so far you were in the machine learning sandbox. You could not really break anything. Now if you deploy by accident the wrong model, or if your model doesn't scale, all kinds of things can go interestingly wrong. Then you start breaking productions, potentially disrupting business apps and users, losing money. Yeah, life's not good. Okay, and in the process you're going to do debugging and so on and so on. So again, DevOps. Okay, and you thought you would do data science, right? And again, 80% of your time end-to-end is spent doing something else. So that's the problem that Sagemaker is trying to solve. We're trying to help you with data cleaning, data preparation by providing built-in algos that do some of that, providing you with your tools to do that, providing you with managed infrastructure to train and deploy, and really trying to cut that 80% frustration to something that's significantly smaller. Okay, so that's the purpose. So Sagemaker comes with a number of modules. It's not, like I was saying this morning, it's not like a big monolithic service that you have to use. Okay, so it's not Amazon's way of doing machine learning, and you enter here and you exit here and just follow the path and you have no flexibility. You use all of this through an SDK that I will cover in a minute, and you get to pick what you like and you get to drop what you don't like. Okay, so whatever fits your purpose, fine. Don't use the rest. Okay, so notebook instances, pre-installed EC2 instances to get to work quickly. So dev environments, experimentation environments, that's what I'm using later on. Nothing to install, just click and get to work. Built-in algos, we'll talk about those. So off-the-shelf algos that you can use to solve typical machine learning and deep learning problems. Just throw your data at them and start training. No coding, no machine learning coding required. And the built-in environments for deep learning as well. TensorFlow, MXNet, PyTorch, etc. So you'll never install TensorFlow again. You'll never install GPU drivers again. I can promise you that. Okay, and you'll save a lot of time. And we keep optimizing those for performance as well. So one of some new features that we added at reInvent are, I guess, productivity features like Git integration. So now you can add your favorite repositories to Sagemaker, and elastic inference, which I explained this morning, the ability to attach acceleration to a notebook instance and to any EC2 instance. Okay, so Git integration is what you would expect. You can either use code commit or internal Git service, or you can connect to GitHub, GitLab, etc. and reference your repositories into SageMaker so that your developers, your data scientists have easy access to that. Okay, just a simple thing to do. Elastic inference for notebook instances is super easy. So you pick the instance type that you need for the actual notebook instance where you will be running your notebooks. And it doesn't need to be really large, okay? I'm going to be using T3 today. And that's the inexpensive choice, and it's a reasonable choice because chances are you will not run heavy-duty computation on the notebook instance. You are running the notebook itself, and maybe you're doing basic pre-processing, but you're not doing the heavy lifting on the notebook instance. You could, right? You can go and run crazy large notebook instances if you really need to, but chances are some T2, T3 is the right choice. But still, maybe you'd like to have some acceleration attached to that. Maybe you want to experiment with a subset of your data and you're doing image classification or something. So it would be cool to be able to do everything on the notebook instance, and having some kind of acceleration is nice. So you can just do this, select medium large, extra large acceleration, and you'll get that. And actually I've got one of my notebooks use that. Local acceleration. And then when it comes to built-in algos, so we have new ones. I'll talk about those. We have 17 algos now. We added an extra built-in environment for scikit-learn. So that's a really popular machine learning library. So again, you'll never have to install that again. We have a model marketplace. And that sounds like a simple feature, but it's super useful. We have the ability to search all the past training jobs, because over time you will be training hundreds and hundreds and hundreds of times, and it wasn't so easy early on to find that training job. Say, oh, I remember training with XJBoost last week with this data set. So okay, now I've got to scroll through or go through pages of JSON information. It's not nice. So now you can just quickly search and figure out what that training job was. The marketplace, we mentioned it this morning, is similar to the EC2 marketplace. It's a collection of pre-trained models that are made available by AWS partners. So you could just go and grab off-the-shelf models solving all kinds of problems, deploy them on SageMaker in a couple of clicks, and start predicting. So totally ignoring that full machine learning cycle that I showed you. Just grab something off the shelf, predict, job done. This might work. And if you're a machine learning developer or if you're a machine learning company, you could obviously publish your own models in there, right? And make money out of that. Why not? Okay, interesting topic. When it comes to training, you can train in just one click or one API call at any scale without ever managing a server. You can tune your hyperparameters, so automatically figure out the right parameters for that training job. I'll show you an example later on. And we added a few things. So I mentioned this morning the new P3DN instance family. So even more powerful, still based on the NVIDIA 100, supporting 100 gigabit networking for faster training. C5N, again, more CPU based. 100 gigabit networking for the bigger ones. And the fastest single core clock speed available at 3.5 gigahertz. We optimized TensorFlow to scale linearly up to 256 GPUs. And now if you do hyperparameter optimization, you can actually resume for a previous job. You don't have to start all over again. And when you have a model that you like, you can deploy it. Again, super simple. You can either deploy to fleet of fully managed web servers and serve HTTPS predictions, or you can use batch transform if your use case fits batch prediction better, okay? And we added a few things. So here you could use elastic inference as well. So you could deploy to instances that have the right type and attach acceleration to that. You can use Neo to compile the model for a given hardware architecture. I'll show you the Raspberry Pi version of that. And we have another feature called inference pipelines that I'll cover at the end, where you can actually chain multiple models to do predictions. So that's useful if you want to do pre-processing, prediction, post-processing, things like that. So you can actually have a chain of models that are called in sequence to build predictions. So how do we work with this? So like I said, it's all driven by APIs and a high-level SDK. So that's what we refer to as the Sagemaker SDK. So high-level Python SDK for algo selection, training, deploying, tuning, etc. And you will see, when I say high-level, I really mean it. You don't get into the nitty-gritty details. You end up writing very little code. There's also a Spark SDK that you can use on your in your Spark applications. So it could be on-premise Spark, or it could be EMR Spark. And we have a Python version and a Scala version. I won't cover that today because it's already very full. If you're a Spark user and you're curious on how to integrate Spark and SageMaker and why you do that, etc., ask me questions at the end. But it is very, very interesting. Of course, you could always rely on the AWS SDKs. So these are the API level SDKs available in the command line interface or in all the language SDKs. So Boto 3 for Python, etc. These are I would say low-level APIs. Okay, so for experimentation and notebooks, etc., I'll definitely use the high-level SDK because it's so convenient. For production, automation, infrastructure level work, etc., where you want to have fine control, etc., probably the lower level SDK is a better choice. So under the hood, it all works with Docker containers. Okay, so that's not scary because in 99% of the time, you don't need to know the first thing about Docker. So let me explain how this works. We have a collection of Docker containers storing the built-in algos and the pre-built environment for TensorFlow and MXNet and etc. And they're available in Amazon ECR, which is our internal service, our internal repository for Docker images. Okay, so we build them, we push them there. So once you want to use them, what you really do is you write. Here it is. Okay, you write this, what I call this helper code. So that's the notebook part or your Python script. And you will just use the SDK to select the algo, select the container that you want to use, define where your data lives in S3, set some parameters, train, and that's it. Okay, so it's very, very little code, as you will see. And so once you do this, SageMaker fires up the training infrastructure based on what you ask for. And it will train the model, load your data from S3, get everything going. Once the model has been trained, it saves the model back to S3 and shuts down the training instances. Okay, so you will never overpay for training. You will never leave training infrastructure running for nothing, okay, because it's terminated automatically. As we discussed earlier, you could stop there. You could grab the model in S3 and you could deploy it on your laptop if you like. Or you could bring into S3 a model that you already trained. That works. And then you could go and deploy it. And it works exactly in the same way. Write a few lines of Python saying, okay, please deploy this model to these servers, okay, this number of servers with this instance type. And again, SageMaker is going to create all of that, pull the right container, inject your model, create the prediction endpoint, all fully managed. And you can use that endpoint to perform predictions. Okay? And it is really HTTP posting to the endpoint, posting your data, getting back results. So that's how it works. So like I said, today we're not going to go into custom containers, so we really don't need to know anything about Docker. You could really run anything in there. Okay, so these are the options: built-in algos, built-in environments. So I call this bring your own script, because you just bring your TensorFlow code or your MXNet code into an existing environment, or bring your own container. So if you have your in-house C++ library for prediction, and that's what you want to run on SageMaker, fine. Just build a Docker container following some simple guidelines, and push that to ECR, and then you can use it on SageMaker to train and deploy. Okay, so if you use something that's not in that list, it's okay. It's very, very easy to do. If you use R, if you want to use Java, if you want to use any other language, Fine. Build a container, put the training script, the prediction script, and SageMaker will figure it out. Okay, and you can scale that. So let's focus on the built-in algos, which I think are one of the key interesting things in SageMaker, especially if you're just starting with machine learning. So there's a bit of a color code here. So it's looking better on my screen than on this screen, but that's okay. So the lighter orange, which is supposed to be yellow, is unsupervised learning, and the proper orange is supervised learning. Okay, so we have 17 algos. Some typical ones like linear regression, clustering, KNN, PCA, factorization machines, stuff that has been around for decades. But these are really Amazon versions, right? These are Amazon implementations. So they'll scale to the moon, hopefully, and more. And we also have some slightly more advanced things, like anomaly detection, blazing text, which I'll show you in a minute, which actually Amazon invented, DPR for forecasting, that also was also invented by Amazon, and a few deep learning ones, for classification, detection, and segmentation. So it does cover quite a lot. So before you go and decide to build your own convolutional neural network to classify images or detect images, well, why don't you give those a try, right? And you'll save months, right? And lots of trouble. These might just work out of the box, and you can train on your own data, okay? So actually, let me show you a first example. So I'm going to use blazing text, because it can't just be about images, right? So blazing text can be used in two modes. You can use it to compute word embeddings when you work with text and natural language. That's usually one of the first steps that you run. You get rid of the actual text and transform every word into a vector that can be used by the machine learning model. So that's not what we're going to use. We're going to use it in a slightly higher level fashion, doing supervised learning and actually text classification. Okay, so let me switch to my. Let me switch to this. So here's my notebook instance. Again, just for the record, this is how you create one. You go to the SageMaker console, and of course you can use APIs. You give it a name, select a type, decide if you want acceleration on that, if that needs to run in a VPC or not. A few more things. Grab a repo that could be in your list and create it. Wait for 2-3 minutes and you can get to work. Okay? And then you'll see it in your console. Click open and you jump into your Jupyter notebooks directly. Okay? So super easy. Okay, so let's look at blazing text. So I'll try to go reasonably slow on that one because it's the first one. But the important thing to focus on is the workflow. Okay, don't worry about the tiny details. Don't worry about that. Focus on the workflow, the steps that are required to get the job done, and the SDK APIs that I will be using. Because this is really what you will see in every single notebook. Okay, we have a growing collection of notebooks on GitHub. The URL is at the end of the presentation. And I don't know, there must be maybe close to 100 notebooks in there. So it's a lot. They show you how to use SageMaker, and they all have that same structure. So that's what you should focus on. So import some libraries, grab an S3 bucket, because that's really one of the key things. Your data must be in S3. Okay, so if your data set lives in Redshift or DynamoDB or somewhere else, you need to put it in S3. Okay, and there are plenty of options to do that. We're going to download the data set. It's a DBpedia data set. It has 560K training samples. So let's download everything to the notebook instance, extract it, and look at a few samples. So the samples are sentences, right? Labeled with a class, okay? That's an integer value. And those classes are the following. So we have 14 classes describing what that sentence is about. Okay, so the name of the game is to build a classification model that will be able to figure out in which of those 14 categories your new samples are. Okay? All right, so load that stuff in a dictionary. And here it's a reasonably clean data set. It's a reference data set. So we don't need to do much pre-processing. The only thing we'll do is tokenizing. So tokenizing means we want to guarantee that all words are space separated by a single space, and that punctuation is also space separated. Okay, so if you have word, comma, space, we're going to turn this into word, space, comma, space. Okay, we need one single space between each word and each punctuation symbol. So we use NLTK, a natural language toolkit. It's an open source library to do this. Okay, don't worry about that code. It's vanilla Python code. So we just tokenize the data set. We have a training set. We have a validation set. Okay, pre-process everything, and then upload to S3. Okay. And Sagemaker needs that training data and that validation data to be split. Right. That's what Sagemaker calls channels. So we need one location, one prefix, one S3 prefix for the training data, and we need one S3 prefix for the validation data. Okay, and these are the two locations that we use. All right, we need to define an output location, which is where the trained model will be written. And that's about it. Okay, so of course, for real life data, you would spend weeks cleaning it. Okay, but at some point, it's clean, it's split into training and validation, and it's in S3. So now we get really to the Sagemaker part. So the first thing we want to do is what algo do we want to use? Okay, so, well, blazing text is the one here. And remember what I said about containers. All that code is in containers. Well, sounds complicated. Not really, because you could grab this, you could use this very friendly function to grab the name of the blazing text container in the region I'm running in. Okay, ECR and Sagemaker are regional services. So we have copies of that blazing text container in each region where Sagemaker is available. So we just grab the region name, and I'm running in US East 1 here, and just asking Sagemaker, okay, give us the image name, the Docker image name for that blazing text container in US East 1. Okay, and it looks like this. All right. And this is as much Docker as you need to know when you're working with built-in algos. And yes. Oh, sure, of course. Is that better? All right. Okay, so this is what you get, the Docker name, and that's what we're going to pass to the API. Yeah?
How do you manage dependencies?
Sorry?
How do you manage dependencies? Like the NTK, for example. Where do you install
So I install, so you can, so on the notebook, so all this stuff is running on the notebook instance. And so I guess NLTK was already installed on that. It's probably part of the Python environment that we provide on the notebook instance. If you need to install anything, you just pip install whatever. All right, let me start breaking things. Okay, so yeah, it's already installed, but that's what you would do. Of course, it's there, but I didn't take any risks. Okay, so you can do this. So in your notebook, you can pip install and do whatever you want. You can run shell commands with the exclamation mark. There's another way to do this automatically. We have what we call lifecycle configurations, where it's like user data for EC2 instances. So you can actually automatically run an installation script whenever you start a notebook instance or create a notebook instance. Okay, so that's the problem, and that's of course the preferred way to do this. And this is where you would maybe clone your GitHub repos and so on. Okay, but when you're experimenting quick and dirty, you can do this. And if you're really if you're really anxious about the CLI. You can always open a terminal and fire away CLI commands, right? And by the way, I want to mention that this is all the different environments manage with Conda. Okay, so to manage different environments for Python 2, Python 3, MXNet, TensorFlow, blah, blah, blah. We have pre-existing Conda environments, and you can add your own. So you avoid messing up your Python environment just like I did on this Mac, and it's hopeless, right? So that's why I'm using notebook instances. Okay, thanks for the question. All right, so let's get back to training. Okay. All right, so we grab the container, and okay, well, ignore this text. What we really want to do now is configure the training job. So that's probably the most important object in the SDK, that estimator object. It's the generic object to configure training jobs. Okay, so let's look at the parameters. So we pass the container, specifying the algo that we want to use, the role, the IAM role for Sagemaker, which we grabbed in the first cell, I think, because Sagemaker needs permission to access S3, blah, 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 blah. And then how much infrastructure do we want to train on? Okay, so here we will train on one C4 4XL instance. Okay, and this is as much infrastructure as you will have to deal with. That's it. Okay, if I was working on a crazy large data set, I would say, all right, give me maybe 100 instances. And this is the only thing I'd do, right? No work needed. Just say how many instances you want and what type they should be. So for built-in algos, actually the documentation tells you the recommended instance type. Okay, but feel free to experiment. And then, okay, those parameters are really nothing to write home about. The output location. This one is important, input mode. So input mode is how the data will be actually sent to the training instances. So file means we're going to copy it. Okay, so we copy the full data set to the training instance, which is fine when you have small data sets like this. If you have a really large data set, you can shard the data set across the training instances. And if you have crazy large data sets, you can use pipe mode. Okay. And pipe mode streams the data from S3 to the training instances. The benefit being, one, you save training time by not copying stuff, so you start training faster. And second, now you can train on infinitely large data sets. So if you could stream a petabyte of data if you wanted, okay? It doesn't matter if it doesn't fit in memory, because Sagemaker will just stream chunks to the training instance. So you could train on infinitely large data sets. This is supported by almost all the built-in algos and TensorFlow. Okay, so we still have to do a bit of machine learning, right? We need to read the algorithm documentation, and we need to set some parameters. So why not take a look? Okay, so that's the Sagemaker doc. And let's look at the classification hyperparameters. Okay, so we'll stick to the required ones. Okay, so, okay, training mode, that's an easy one, right? There's only one value, supervised. Okay? All the other ones are optional. Right? So why did we bother using them? Where's that thing? Here it is. So actually I could just do this, right? Okay, but whoever wrote that cool notebook wanted to go a little fancier, but my actual recommendation would be, if you're not super familiar with those algos, stick to the default parameters, okay? See what kind of accuracy you get, and then read a little more, read the research paper for blazing text, and you can go a little deeper and figure it out. Or you could do tuning, as we will see later. But you could stick to this, right? Okay. The other ones are just slightly more advanced, but again, do some reading. Okay, I need to define where my training set is and my validation set is using the prefix that I defined earlier. And then I just do this. Fit. Okay, so when I said one API call to get things going, here it is. You call fit on the estimator that you configured, passing the location of the training channel and the validation channel. and off you go. Okay, so SageMaker creates that instance, pulls the Docker container to it, injects your parameters, injects the location of the data. Those two things are actually written as files inside the container. That's how SageMaker does it. It writes that information into files inside the container, and then the algo picks up that data. And then we train. Okay, so lots of logging. Very nice. Validation accuracy is 97%. Yeah, I can live with that. And we train for 46 seconds. Okay, so this morning, if somebody asks you, we need to build a classification model for text articles, right? And how long is it going to take? Well, you would have thought about it and say, yeah, I don't know. Well, I need to think about it. Okay. So now it's literally taking 46 seconds, right? Because you don't need to write machine learning code at all. You look at this notebook, you adapt it to your own problem, and you train. And without knowing much, you get to 97% accuracy, which is kind of good. Okay. The cost of this is 46 seconds of C4 for Excel. So pennies, right? Okay, so we're happy with that, and we want to deploy it. How difficult is that? Well, it's one line of code. Deploy it to one M4 Excel instance. Again, yes?
Which framework is behind that?
So, good question. So the question is, which framework is behind that? So all the built-in algos use MXNet, except XJBoost, which is an open source algo, so it uses that implementation. Okay, but it's an MXNet model. So you could go and grab the model from S3 and load it in MXNet. Okay. Yeah, so you just decide to deploy on that M4 Excel instance. That SageMaker will completely manage for you. Wait for a few minutes for the instance to show up. If you look at the SageMaker console, you should see that endpoint somewhere. Blazing text, here it is. And here's the URL. Here it is. Okay, so this is the actual URL of your model. So like I said, you could HTTP post using your favorite language, or you could, in this case, you could keep it simple. We have a predict API in the SDK that performs that invocation. So here we take a couple of sentences. The one is clearly about a company. The second one is clearly about a college. We apply tokenizing. Okay, that's important. You need to apply to your real life data the same processing that you applied on the training data. So tokenizing everything, making sure we have space separated everything. And what's going on now? I don't see that prediction. Okay, it got stuck somewhere. Okay, let me. So this notebook decided to have a life of its own. Can I run this now? Okay, here we go. Okay, so here I use the predict API to predict those two sentences, and I get the top one probability here. So 99%, it's a company-related text. 99%, it's an educational institution text. Okay. Which makes sense because this one said company, so if we say firm, run that again. All right, so yeah, not telling you it's a company actually drops the probability. Yes. Yes. Sure. So the question is, what if I have some very specific custom pre-processing that I need to run before predictions? So here, obviously, it's a toy example. We're not doing that. So two things, two options. So if you're already using Spark and you can do ETL on Spark. So you're going to do ETL for training, but you could do live ETL for prediction as well. And you could invoke a SageMaker endpoint directly from your Spark cluster using the Spark SDK. Okay, that's actually one of the scenarios where that combination is interesting. The downside to this is you need to have a Spark cluster running all the time. So if you have one, if you need one all the time, fine. That's right. That's okay. If you don't need it all the time, then that inference pipeline feature is actually a good option. So you can I'll talk quickly about that at the end, but in a nutshell, you can train a pre-processing algo in scikit-learn or Spark ML, and that could be trained on a Spark cluster. Okay, if you on your existing EMR, then you could grab the model. It's saved into mleap format. Okay. Sorry if this is really Spark specific. And you can terminate the AMR cluster. So you have this mleap container. That can be the early step in your inference pipeline. So run pre-processing with that Spark trained algo, and then chain that with a proper prediction using anything else, a built-in algo or TensorFlow, etc. Okay, does that answer your question? All right, thank you. Very good question. Thanks, I could clarify that. I'm happy I could clarify it. So, all right, and we could keep going, and of course at the end we could decide to delete the endpoint to stop paying. Okay, so just to be really clear on the pricing model, you pay for the notebook instance per second, depending on the instance type. For training, you pay per second multiplied by per second for that instance type multiplied by the number of training instances that you use for the training job, and for the endpoint, it's the same. Right? The only difference is the endpoint stays up until you delete it. So the only way to waste money with Sagemaker is to actually forget to delete your endpoints. Okay? So let's not forget. Right? And it goes away. Okay? All right. That was a long example. Let's keep going. So what about deep learning? So deep learning, like I said, we support built-in environments for TensorFlow, MXNet, PyTorch, Chainer, etc. But you also get optimized versions. So this is an example of training TensorFlow on image classification models. So the blue bar is the vanilla version, the one you could get in the TensorFlow repo. Okay, and the higher is better, as you can imagine. So that's the number of images you train per second. And the orange bar is the TensorFlow version in Sagemaker and the deep learning AMI. Okay, thanks to optimizations that our teams do, you get 5x to 7x speed up. Okay, this is from about a little less than a year ago, and this is really significant because if you have the training job that takes 6 hours, now it takes 1 hour. So you can train 5 or 6 times a day, iterate faster. This is a more recent benchmark on, again, training on C5, and it's 11 times faster. So we keep accelerating. Okay, so the versions, the TensorFlow versions, and it's true for the other deep learning libraries, the other versions that you get, the deep learning libraries that you get in Sagemaker are super, super optimized. So it's not just managed notebooks like I hear sometimes. There's a lot of value in using those. So let's look at a TensorFlow example, and I will actually run everything on the notebook instance, and I will use elastic inference. Is that? No. Where is it? That's the one. Okay. Okay, so in the previous example, I actually fired up training instances and prediction instances. Okay, here I'm going to use something called local mode, which is very, very nice for experimentation, where I'll do everything locally on the notebook instance. So it's saving me time because I don't have to wait for those training or prediction instances to come up. I can iterate faster, and of course, I save the cost of using those managed instances. So it's a cool way to experiment when you have, a subset of your data. So here we're going to build a simple convolution neural network that learns to, oh no, it's not a convolution neural network, sorry, it's a net example. This is a simple, fully connected network learning to classify the iris data set. Okay, so it might be one of the oldest image data sets out there. Well, these are images, but it's actually a text data set. Sorry, getting confused now. It's a small one. It has 150 samples. It was built in 1936, right? So somebody went in the forest, or I don't know where, and they measured 150 flowers. So, sepal length and petal length, etc., etc. So 4 features. And they wrote down what type of iris that was. And there are 3 types, okay? 0, 1, and 2, okay? So let's try to see how we can do something with this, okay? So it starts the same. Put the data in S3. Write, this time, a bit of TensorFlow code. So this code is vanilla TensorFlow code that you could run on your own machine. Okay? No modification. If you're used to TensorFlow, you know about those functions, right? Serving input fn, train input fn, eval input fn. So functions, loading the training set, loading the validation set, serving predictions, etc. Those are standard functions that you're usually writing when you build a TensorFlow code. And here's actually the function that builds the network. So like I said, it's a simple, fully connected network, 3 hidden layers, 10 neurons, 20 neurons, 10 neurons, and on the output layer, 3 classes, right? 3 neurons because we have 3 classes. So as basic as it gets, okay? So if you don't know TensorFlow, no worries. Just remember, just grab your code, put it in there, and if it's proper TensorFlow code, it's going to work. Okay, there we go. Detailing all those functions. Now configuring the training job. Okay, so this time we use the TensorFlow object. Yes?
Sorry, do you really need the functions to be defined in a different file, a different Python file?
Yeah, so yeah, sure. It needs to be a separate file because the container will load it. Okay, and I think it's good practice to separate the actual learning code from the experimentation code, especially if you want to reuse it and deploy it in production. I hope no one is actually running notebook code in production. Okay, but I'm not going to listen to the answer. Okay? Yeah, I hope not. Okay, this is for experimentation. Okay, then you actually write proper code and you do unit testing and so on. Yeah, of course. Okay. So same story, right? We're going to train on the local instance type. Okay, so again, not firing up anything, just running locally. Okay, and we train. Okay, and as you can see, it starts immediately because we don't have to wait for that instance to come up. Okay, so this is super fast. Trains for a few seconds. And then I want to deploy that model and see how well it does. And this is where so I still use the deploy API. The instance type is local, again. And I just say, hey, you know what? When I created this notebook instance, I attached an accelerator to it. So why don't you go and use that? Okay? And so the local predictions that I will do now will be accelerated. Okay? Keep in mind, this is only for prediction. Okay? Elastic inference is elastic inference. It is for prediction only. We are not accelerating training, we're accelerating predictions. Okay? All right, so deploying that model locally and then predicting things. And this is extremely verbose. Okay, so passing those 4 features. All right, so we went in the forest, find an iris flower, measured some things, and now we want to predict. Okay, and we see that without much of a doubt, this is classified as iris class 1. Okay, all of that stuff happened locally, but still, if we had bigger data and more complex data, you could still use acceleration locally to experiment. And then, of course, when you want to train at scale, you can just go and fire up proper instances to train at full scale. But for experimentation, this is as fast as it gets, right? And this is a better option than training on your laptop that doesn't have a GPU, for example. Okay, we're not done. Take a deep breath. All right, so, okay, now we have a model that we like, but is it the optimal model? We picked some hyperparameters, right? Remember for blazing text? They looked weird. How do we do that? So there's a technical automatic model tuning, and it's about finding the optimal set of hyperparameters. So there are 4 ways you can go here. The first one is manual search. I know what I'm doing. Yeah.
Sorry, just before we go to the next chapter. So far, like I never used Sagemaker before. It sounds like cool. If the company never had this kind of pipeline to train the data. My question is, if I already use Spark and the Spark has machine learning, the two things has moved.
Yep.
Like, in what kind of scenario I could convince myself use Sagemaker instead of like a Spark machine learning?
So I'm running a little late, so I'm going to take the shortcut to that answer. I'm going to answer it, but come talk to me later on. So short answer is scalability, right? Maybe you're facing really big training jobs, and it would not be cost efficient to scale your EMR cluster, right? The second thing is maybe you need an algo that is not available in Spark ML, okay? And deep learning is typically not there. So any deep learning things should go there. And maybe you want to be smart about picking the right instance type for ETL and a different instance type for training. So when you work with Spark on EMR, you have to make a compromise, right? So you need lots of RAM for ETL and lots of computing power for machine learning. So where do you set that threshold? So the best way is to actually separate those concerns and say, I'm going to do ETL on Spark, and I'll take the RAM optimized instances, and I'll fire up training jobs on SageMaker using GPUs or C5, the compute optimized instances, and I get the best of both worlds. And communication between the two is completely seamless. So you pass the data frame to SageMaker, so no weird processing, and SageMaker returns the data frame to you. So it's completely transparent. Yeah, we have some samples. So the question is, what about pre-trained models? We have some notebooks. I'll point to you at the end, okay, the pre-trained examples. So back to model tuning. So I know what I'm doing, except I'm not. So you're going to spend a lot of time testing combinations that don't work. So the scientific way is, let's do grid search. Let's systematically explore the space of hyperparameters. Thing is, you're going to spend a lot of time training. You're going to train hundreds, if not thousands of models, hoping to zoom in on that hot spot in the hyperparameter space. So super slow, super expensive. A lot of people use random search. So spray and pray, just pick 100 or 200 combinations of hyperparameters in the hyperparameter space, and just try your luck, right? Funny enough, this generally works better than grid search. Better and faster. So it's not intellectually satisfying, but I would recommend that instead. Or you use actually HPO, which is really using machine learning to predict the right parameters for the job. So we train a few times, picking random values, look at the accuracy that we get, and then apply optimization on that. It's called Gaussian process regression and Bayesian optimization. Try saying that 10 times. I recommend it if you can't sleep tonight. And using these machine learning optimization, you actually pick the next 2 or 3 jobs. And you do that again, and you have those new data points, parameters versus accuracy, and optimize again and again and again and again. And gradually, you tend to converge really quickly to pretty optimal parameters. And typically, random search, grid search, we're talking hundreds of models, maybe thousands. HPO, it's an order of magnitude less. You can get to really good results in 50 trainings, right? It depends how many hyperparameters you want to optimize, but that's probably the scale, right? We're talking tens of training, not hundreds of trainings. So let's look at a quick demo. And here I'm going to run, that's the one. So I'm going to run learning rate optimization on a simple convolutional neural network in TensorFlow. Okay, so we're trying to learn the MNIST dataset, the handwritten digits. So we download that, upload them to S3. Same old. This is the convolution neural network in TensorFlow. So separate script. You could run this on the laptop. 2 convolutional layers. Okay, very, very typical. Yeah, it's actually the vanilla TensorFlow example, I think. All right. And so we set up the estimator for TensorFlow. And this is the exact same one as we saw before. No difference. And instead of calling fit, as we did in the previous example, we're going to say, hey, let's explore learning rates between 0.01 and 0.2. That's my range. So go and explore that, train a number of models, and find the best one. Okay? So I need to define the metric that I want to optimize on. So here I want to minimize loss, so prediction error. Okay? And I configure the hyperparameter tuning job saying, okay, using this estimator, using this metric, using this range, please run 9 training jobs, 3 by 3. Okay, so we'll run 3, optimize, run 3, optimize, run 3. That's 9, right? I think. Okay? And then we call fit. All right? And if we look at the console now, we actually see, here it is. Okay, so we trained 9 jobs. Here they are. And then we see the loss, the metric we want to optimize on. Okay, and the best of the 9 is, oops, I didn't click on the right thing. No, sorry, got lost. Okay, here we go again. Okay, so the 9 training jobs, and the best one is here. Okay, and this one has a 0.52 loss, whatever. And the learning rate is 0.0822, whatever that is. Okay, that's not a value you would have tried, right? And it's interesting if you compare this to other training jobs, a tiny variation in the learning rate, which is the single parameter we're looking at here, gives a has a really big impact on the training loss. So these are not values you would have tried. You would have tried 0.01, 0.02, the typical stuff. So imagine with 3, 4, 5, 6 hyperparameters. Okay, so manual search, trust me, you don't know what you're doing, and neither am I. So HPO is the way to go here. Okay, super simple to set up. All right, the last thing I want to show you before they kick me out is compilation. Okay, so now you have a model. You trained it, you optimized it, and you want it to run as fast as possible on your own machine, right? So this is what Neo does. Okay, so it supports TensorFlow, MXNet, PyTorch, ONNX, and XGBoost. It optimizes for these architectures, more to come, and as I've said earlier, this will be open sourced for other hardware vendors to run. So how difficult is it? Not very. So you configure the training job, okay? So defining where your model is in S3, okay? And I might switch to that. That's probably a better option here. Switching to my Pi. Try to keep both things on the screen. Yeah, it's super tiny. Okay. Still alive? Great. Okay. So I would train a model on Sagemaker, grab it from S3, and it would look something like this. Okay, so here it's a ResNet model here in MXNet. So I would have a parameters file and a JSON file describing the model. Okay, so that's what you would have in that tar archive here. Okay, it's really the output artifact from your Sagemaker training job. You need to define the input shape. So it's an image classification model. So yeah, actually, I think I have the file here. So it predicts, where is it? It predicts, no, it's not here. It's here. Here, you can see it here. It predicts one image with 3 channels, red, green, and blue, 224 pixels. That's the shape it was trained on. It's an MXNet model, so please do whatever you have to do to optimize it for a Raspberry Pi and output something in that bucket. Okay, anyone can write that. Okay? And then I need to run that command. All right, let's run that command. Okay, so that's it. And I could run this one. Ah, probably not. Okay. Ah, it failed. Okay, because all right. I messed something up again. Okay, not a gzip file. All right, fine. Yeah, I know what that is. Okay, my fault. No worries. So you compile it. Within seconds, either it fails because I'm stupid, or you get a compiled version. Okay. And in that compiled version that I copied to the Pi, you get the optimized version of the model. So first, let's try to run the vanilla model. So I'm trying to predict a dog image using the vanilla version of the MXNet model. Okay, so it takes a bit to warm up. It needs to load MXNet. It needs to load the model, and then I read that dog image from, yes, if I pass the right name, I load that dog image from disk and I predict it. And let's see how much time it takes. Okay, it's a Raspberry Pi, so you have to be patient. Come on, buddy. All right, so we predicted it correctly, but it took about 8 seconds. Okay, that's way too slow for any kind of application. Okay? So now, using the compiled version, which looks like this. Okay, so I get, in the archive, I get that same model that I got before, and I got a shared object library that actually contains hardware optimized versions of some of the operators used in the model. Okay, and so that's what I need to load. And I can load it very easily using here it is, right? Using that deep learning runtime. Okay, so here I'm not even loading MXNet on the Pi, right? I'm just loading the model on the Neo runtime and predicting. So you also save space by not installing MXNet or TensorFlow to your device. Those can take up to 1 gigabyte of storage. Okay, so here again, loading the model, loading the optimized symbols, and predicting the same image. And I think it's going to do it 10 times or something. And obviously, this is not taking 6 seconds, right? Okay, so let's look at the log. All right, takes 1.3 seconds. So like I said, 5-6x speed up, which is huge, okay? Because this is so tiny, right, that the minute you start using hardware optimization, you get a massive performance boost. I don't think you'll get that on the other platforms, but this is really significant, okay? So there you go, Neo. And you can apply that to C5 instances, P3 instances. So even there, you should see a nice speed up. Okay, I talked about inference pipelines already. So in a nutshell, a sequence of containers that let you run different models to do pre-processing, post-processing, etc. There's a good notebook on that. So go and run that using scikit-learn, and there's a Spark version as well that you might like. If you're looking for resources, so a lot of them I've already mentioned in previous talks. I just want to point out this one. If you want to have a long and deep workshop on Sagemaker, this is actually the workshop I ran at reInvent a couple of weeks ago. People seem to like it. And you can grab the code and the slides from that repo and run it. And it uses XJBoost, but it's going to take you through the full thing, batch transform, HPO, etc., etc. Okay, so if you want to get really, really deep on Sagemaker, I recommend it. And again, the best information source here is this collection of notebooks, okay, on GitHub. So the repo is called Amazon SageMaker examples. This is the best way to learn. Read the docs and dive into those. Start maybe with the built-in algos. And if you want to go crazy on Spark, you'll find Spark examples as well. Okay, and if you were curious about, remind me, pre-trained models. You'll find examples. Where are they? Advanced. Yes, here they are. Okay, so BYOM means bring your own model. Yeah, it took me a while to figure it out. So they show you how to import a TensorFlow model or other kinds of model. There's even an R version if people like to use R. So again, lots of notebooks. This is a hugely interesting resource, and it covers really, really everything, and it keeps evolving. All right. I'm late again, so is the next speaker here? Oh yeah, all right, so I'm late again. Hey, was late in London, I'm late in Dublin, right? There's some consistency here, so I fully apologize for that. I owe you a beer. And so I'm gonna take a break, and I'm going to prepare for the last session, focusing on reinforcement learning, right? So go have coffee before that, all right? Thanks a lot, thank you very much.